The current standard for enterprise AI is reactive. A user provides a prompt, the system provides a response, and the human manually manages every subsequent step in the workflow. Current models are evolving into autonomous networks, systems capable of planning multi-step strategies and correcting their own errors without continuous manual input. In this reactive model, human staff handle the overarching process. The AI is limited to completing isolated, disconnected tasks. This creates a static bottleneck. You manually copy competitor data, paste it for financial analysis, and prompt the system to draft an email. Autonomous agents function differently, wrapped inside a continuous execution loop that independently breaks a single high-level objective into microtasks. Designing for the modern enterprise requires an understanding of how these systems are built, from basic tool calling up to complex multi-agent orchestration. In an agentic workflow, the human role moves from executing the manual workflow to setting the strategic goal and defining the guardrails. To build these systems, we must address a core limitation. A large language model is an isolated text calculator. It cannot natively browse the web, send emails, or run live calculations. Think of the model as an architect who is paralyzed from the neck down. They have the knowledge to build a house, but they lack the physical ability to pick up a hammer. Tool calling provides that architect with a digital toolbox. It uses APIs to bridge the gap between the model's reasoning and external software execution. During the assessment phase, the AI reads the user's request, recognizes its own knowledge gap, and scans its inventory of available tools to find a solution. The model then issues the call. It outputs a specific text command that tells the surrounding software to activate a specific tool, like a web search. The software executes the search and feeds that text back into the LLM's memory, allowing the model to use real-world data to complete its task. This mechanic is the foundation of agency. It transforms a text generator into an entity capable of impacting the physical software environment. However, tasking a single God agent with an entire business process leads to cognitive overload. When one system handles too many variables, it begins to lose focus and hallucinate. Forcing one isolated model to handle multidisciplinary workflows leads to structural failure when subjected to heavy enterprise demands. Multi-agent orchestration solves this by mimicking a Hollywood film crew. Instead of one person doing everything, specialized agents are assigned narrow, strict jobs to ensure quality. In a sequential workflow, agents work like an assembly line. One agent finishes a task and hand-delivers it to the next specialized agent in the chain. In a hierarchical workflow, a manager agent receives the objective and delegates tasks to worker agents, evaluating their work and forcing them to retry if the quality is insufficient. Engineering teams build these ecosystems using specialized frameworks like Crew AI, Microsoft AutoGen, or LangGraph. Breaking complex workflows into hyper-specialized, peer-reviewing agents is the mathematical path to eliminating hallucinations at scale. With increased agency comes the risk of systemic failure. When agents are allowed to self-correct, they can fall into a catastrophic logic trap. Imagine an agent attempting to use a database tool, only to be blocked by a permission error. If the agent tries to self-correct by simply trying again, it can become caught in an accelerating cycle against an immovable obstacle. This is the infinite loop. The system will execute thousands of API calls per minute, attempting the same failed step over and over. Unchecked, this loop will exhaust a company's token budget and generate massive server bills in hours. This makes the implementation of mandatory enterprise guardrails a requirement, starting with max iterations. Max iterations functions as a circuit breaker, mandating a hard ceiling on autonomy by stopping the agent after a set number of attempts. For high-risk operations like financial transfers, we use a human-in-the-loop pause state, where the agent must wait for manual confirmation. These deterministic boundaries and manual kill switches are what make autonomous AI a viable corporate asset. We can see these principles in action through a supply chain procurement workspace designed to reduce manual data friction. When a request is logged, a triage agent extracts the requirements. This data package is then passed to the next agent in the sequence. The sourcing specialist agent uses its web and database tools to scrape live pricing from multiple approved vendors simultaneously. A financial auditor agent then cross-references those results against compliance and budget formulas to identify the most cost-effective option. A clerical agent drafts the purchase order and queues the email, but the process halts at a human-in-the-loop checkpoint for final review. The system pauses, presenting the compiled research and the draft document to a human manager for a single point of approval. With a single click of approval, human oversight authorizes the system to execute the full complex chain of transactions. This assembly line reduces procurement friction from 4 days of manual coordination down to 4 minutes of processing. Implementing AI as intelligent infrastructure allows human workers to move from the mechanics of data movement into roles of strategic command.